everyone. Welcome to Thought Leadership Thursday. Today we have KPM Analytics with us. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, how they perform during the baking process, and ensure the final product quality meets specs. Their comprehensive range of analyzers are used by food producers throughout the world. And this is so that food producers can improve efficiency, ensure quality, and protect their brand. So today we have Arnaud Dubas, Director of Business Development at KPM Analytics. Welcome, Arnaud.
Hello, Lynn. Hello, everybody.
Hey, Arnaud, I know you, I have known you for a while, but for the people who are here today, can you please tell us a little bit more about yourself and what you do at KPM Analytics?
What I'm doing about KPM Analytics is definitely trying to understand the market needs. So for that, I'm visiting a lot of customers. We almost crossed yourself. I know you're in Singapore. I was in Singapore 2 weeks ago.
I know, I just missed you.
Almost. So, and the reason for that is really working with the millers, with the bakers, with the yeast manufacturers, the additive manufacturers, and trying to understand what are they doing, what they want to look in terms of quality, what they are searching for. And so to be able to propose the best adapted solution, which might be one of the solutions we have, or one solution that we need to develop. And this is one of the benefits of working in a group like KPM Analytics, because we have a lot of different tools that we can be applying for that. One of them is Chopin, so I will be speaking more precisely about Chopin because my background is about milling and baking, but I have been working for Chopin over more than 35 years. So that's basically everything I can do. But now we are part of a bigger group, and because of that, we are now able also to bring, you can see here on that side, there is a white box here, which is an NIR device. So we are making analysis for composition like protein, moisture, fat, these kind of things. We have other brands like PSC, which is also analyzing online these kind of moisture properties.
I was just going to ask that. I mean, what other analyzers does KPM Analytics carry?
It's quite wide because it goes from analysis of final product. We have a whole range of vision equipment with different brands, which are really looking at the final product properties in terms of size, color, dimension, whatever. We can really put numbers on what is a good and a bad product. And then we can also do analyze online or at line, which can be with NIR machine like PSC. But we can also do testing at line with a tool like the Alveolab, for instance. I will detail that a little bit more or speak a little bit more about that in a few moments. But we can also analyze the raw material like flour. So we are going to analyze flour with the Alveolab. We're going to discuss that today with NIR and with other kinds of equipment. And we have another part of the company which is also doing analysis of water and the quality of water, which is called SmartChem. And that's a very, very nice to work in such different dimensions.
That's interesting. So today we are interested in talking about the special machine behind you. What is it?
This one, oh, moving.
Yeah.
This one is an Alveolab. You know, the name Chopin comes from the founder of the company, Marcel Chopin. He established the company in the 1920s. And the first device he invented was an Alveolab.
That is so neat.
Where everything started from. And it's very amazing that more than 1 century after, we are still using the same tool. Of course, if you are comparing this new Alveolab I have behind me to the first version of Alveolab, it's somewhat different. And but we kept the principle always. And what is the principle of an alveolab? It's basically simple. It's about blowing a bubble, and we are going to blow the bubble in this chamber here. And we are going to place a patty and squeeze it, inflating or injecting air here. That will develop a bubble. And on this bubble, we are going to measure certain properties, very interesting for the bakers, such as extensibility, tenacity, elasticity, and the baking strength. So this was really the beginning of everything. But then Marcel Chopin had another idea. He said, okay, if I take whatever type of dough, I can have a lot of variability depending on the mixers and everything. So that's where he has been adding a second part to the alveolab, to the alveograph at this time, which is the mixing chamber that we can see here. And this mixing chamber enables us to mix about 250 grams of flour with water to mix it. And then by this little dough here, we are going to extrude little patties, like little cakes, little cookies. And this is what we are going to inflate afterwards. And that makes a complete system. So we can really take the flour, make the dough, and analyze the dough in very similar ways. Because at the beginning,
I think it's an excellent idea. I mean, for some of the bakers out there who aren't familiar with this instrumentation, it is actually like blowing a chewing gum bubble, simulating the effect of fermentation and gas and how you contain the gas in there. So basically, Arnaud, can you bring us through, for example, what kind of graph does it produce? I mean, what would the graph show?
The graph is showing, in fact, the description you have been giving about the chewing gum is a nice similarity. We could also compare it to blowing a balloon, and everyone who has kids, they know the birthday parties and the moment where you need to blow about 50 balloons. And what we are doing with the Alveolab is the same thing, and you have the same feeling. The first thing, when you are blowing a balloon, you are going to feel a resistance of the balloon. Sometimes it's hurting there.
Correct.
So you need
to
pass this.
Be like,
resistance.
It's for
That's the height of the curve, which we call the pressure.
Okay.
And this pressure is related to the resistance of the dough. In terms of baker, this is the tenacity. When we are squeezing the dough and we are looking a little bit the feeling. So the harder it is, the higher will be the curve.
Okay.
And then we go on the second step. Second step is that when we overcome this resistance, the balloon will start blowing. And that the same happens on the alveolab. So the more it can blow, it means the more air it can retain, really. So higher volume makes bigger bubble, eventually higher volume of the final product.
Right.
And balloon, if you continue putting air, at a certain time the balloon explodes, and that's what happened with the Alveolab, and that gives us the information on the extensibility. Extensibility is very important if you are doing pizza, for example, or flatbreads. You want it to be expanded tortilla. You need to have good extensibility, but you don't want to have too much elasticity, because elasticity makes the pizza shrink. So we are also measuring in a part of the curve, we are measuring the elasticity. So that's what makes the Alveolab a very good tool for understanding the dough, and particularly when we are shaping the product.
So can then the Alveolab see the action of, say, additives in the dough? It does,
and particularly all the additives.
Can you give examples?
Yeah, all the additives which have an impact on protein, particularly. If we take the example of ascorbic acid, ascorbic acid is weird because at the beginning it's relaxing, it's a reducer, but then it becomes an oxidizer with the mixing, with the oxygen and so forth. It works very well on the alveograph. And so when you add this ascorbic acid, you are going to see the tenacity increasing because you're strengthening the gluten. And because you are strengthening the gluten, and if you do not change the water absorption, you do not put more water, then the dough will be less stretchable. So you will have a higher p-value and a lower L value.
I see.
But we can work on the other end. We can work with, for instance, reducers, which are helping having a more softer dough. And if we are using cysteine or glutathione, and if we're adding this product, then we will see the opposite effect. The tenacity will decrease and the extensibility will increase. And it's very interesting because it's not like, okay, you say, I'm going to add 10 ppm of the product and this will happen. It's not that simple. That depends on the flour. With some flour, you will see a big impact, and in other flour, you will see less impact.
Right.
So product, the more you add, the more impact you have. Other ones, you have a maximum impact at a certain dosage. So you need to know exactly what you need to put. Because sometimes, yeah, this product can be expensive and you don't want just to put product for putting product. So these
That's
are for
true. You know, so I think the next natural question to ask is, why are some bubbles bigger than the others?
the size of the bubble.
What makes bigger bubbles? We want to know.
We like big bubble. What makes a bubble big is the property of the gluten to stretch. Really, we really have to see the analogy with the balloon is really true in that sense. I mean, if you have a balloon which has the potential to hold a huge volume of gas, then you will blow a very large balloon. That's exactly what happened here. The bigger the bubble means we are able to retain more gas, but it also means we have the possibility to extend the dough, to expand the dough wider. Typically, if you think about always taking the example of the pizza, because that's the most obvious. But when you're taking a piece of dough, a bowl of dough, and you want to expand it to a certain dimension, you need to have a dough which is able to spread easily.
Right.
If you have a big bubble, it means that it will spread easily.
Interesting. Okay, that's great. The market now is seeing quite a bit of whole grain flours. So you know what whole grain does to the dough? It pokes hole in the dough, right? So would whole grain flour give me a bubble at all?
If you had asked me this question 3 years ago, I would have said no. No, and for one single reason. This expansion I was mentioning, when you are putting bran particles into that gluten network, you're breaking the gluten network. You make it more fragile. And that's also the reason why when we are doing bread with whole wheat, most of the time the crumb is more dense because you cannot really expand the bubble as you would like to. In the case of the alveograph, that was making our life impossible. And clearly, if you had too much bran into the flour, it was impossible to make a proper bubble. For two reasons, two main reasons, or three main reasons. The first one is that high fiber or high bran content is increasing the water absorption. So the first thing you need to do is to increase the water you put into the flour. The second thing you need to do is to develop more the gluten so it can surround better all these bran particles. And the third thing you can do, and we can only do that with the Alveolab, which is here, here, maybe here. The only way of doing it with the Alveolab is to do it with the Alveolab, because the Alveolab has potential to totally change the dough testing protocol. And in that case, we are going to blow the bubble much more gently. because we know it's fragile. So we are going to take care of the bubble. And because we have been doing that now with the Alveolab, and only with the Alveolab, we have the potential, not the potential, but we have the capacity to analyze whole wheat flour. And that's a real breakthrough, because until now, we had no real ways of testing the stretchability in the dough in 3 dimensions. You can do that with the bar, but it's not 3 dimension, making a bubble. So it was a real challenge. It took us maybe 5 years to develop this protocol, but today we are very proud that we can say, yes, we can.
That's awesome. Then would this work for gluten-free or keto doughs, may I ask?
Of course, you can ask. So now gluten-free, no. No, gluten-free, no, for one reason. The basis of the alveograph test is based on gluten.
Yeah.
And by definition, in gluten-free product, we are missing the most important part for doing bubbles. So for gluten-free, we have other options. I have been mentioning the Mixolab before. I will not detail the tool, but basically it is a mixing device which is also heating and cooling the dough. And this is absolutely perfect for gluten-free product, because gluten-free, you have a lot of enzymes, it's based on starch, it's a different system, which is not adapted to the Alveo, but very well adapted to the Mixolab. So that's one point. Now the keto. Keto is our new challenge. And you don't see it, but I have one of my colleagues just right there, and she is currently working on a lot of different keto flour and formulations. We did not reach the point where we have been using it on the Alveolab. For the moment, we are analyzing that with the Mixolab, and it's working quite well. The next step will be to adapt the Alveolab to make it, if it's possible, to make it available.
It'll be exciting to see that. Yeah, absolutely. I've seen some of the keto doughs out there that's so resilient and so, elastic.
Right.
It's stronger and more resilient than conventional doughs. So
yeah, we don't know what we have in front of us, but the thing is that yes, we are very keen to look at that and to see if it's possible. The good thing that we know we can make a dough, and when we take this dough and we stretch it, we can stretch it. So we might be able to find a way to make bubble with keto. We hope so, but it's a real challenge. So it's fun to work on that.
Well, that's great, and it's so wonderful to hear that you have such amazing wheat-based the flour and dough instruments that can analyze for flour quality. So I would like to thank you, Arnaud, for coming on today on Thought Leadership Thursday and for sharing your wisdom on the Alveolab and all these other amazing wheat-based instruments that we could use for flour and dough quality. Thank you.
Thank you very much, Kim, for the invitation. It's always a pleasure.
See you. Bye-bye.
See you.